Your Eminences, colleagues, dear friends, participants, first and foremost, I would like to congratulate the organizing scientific and local committee for the initiative and the excellent organization so far of this conference. Indeed, it gives us an overview of a multitude of problems that were of interest to us and concern for that matter. So, I will talk about something that I'm involved in, and that is the skies. So, I'm not a specialist in religious matters. However, I would like to say that after about 50 years that I have been involved with the skies, I will, in fact, summarize my experience in the Psalms, the heavens, in fact, recount the glory of God. Now, let us come to the nitty-gritty, a subject matter which is a bit different from what you have heard before, and will be the continuation of Mr. Dekli said. AI, the EFIA, as was translated yesterday by His Eminence from Navpaktos, and not the Continue Mosini, as it's been talked about so far, because we talked about reasoning and the mind in the terms of intellect. What are the drawbacks and what are the positive points of the use of AI in our field, especially that of cosmology and astrophysics? I had prepared the speech, and last night I asked ChatGPT what its view was. I said, first and foremost, give me an image. He said, good day, what is the subject matter of your speech? I said that it was, in fact, pros and cons of using AI in astrophysics. In 10 seconds flat, it had given me this image here. I found it quite interesting because it has a galaxy in the top left point, and we know in the center most of them have black holes. Around the black hole we have, in fact, atoms and molecules making these disks that go round and round. So from the axis of the black hole we see these particles erupt. We call these jets, and I have been involved in them for the last 40 years, and they travel almost at the speed of light. So far so good. It did quite well, in fact. I thanked it. Indeed, I said, give me another slide about what is happening in cosmology. It said, you have to pay $20 for that. You have to upgrade. Or you could do that tomorrow. It gives you an image a day for free. And let us keep this in mind. There's always interests hidden behind this entire issue. Now, let's look at science. I'll start by the elementary particles. Let's go to CERN. And Greece was a founding member. We have, the collider in the Swiss-French borders, 175 meters below the surface, 27 kilometers. And there we have the local LHC, the Large Hadron Collider. It's the largest such collider worldwide. And about 5,500 people work on this accelerator, more than 3,000 researchers and many Greeks. There, they're trying to find out what is happening in the fundamental composites of matter. So we see these experiments of CERN produce about 60 terabytes per second in terms of data rate. A terabyte is 1 trillion. 1 in the power of 12 for that matter. So every year, 10 terabytes. It's an ocean, a mountain of data. In the logo of Atlas, you see it's fueled by machine learning, AI, artificial intelligence. They do recognize it from the very outset. Here, you're in the realm of AI. And in order to be able to classify all of this and to find new particles are done through artificial intelligence. Now, let's go to the other side of the spectrum, and this has to do with astrophysics, and especially the very beginning of the universe. Here we have more data than there are astronomers to analyze. There are mountains, oceans of data, and the Hubble, the Webb, and other large telescopes of the Space Agency in Chile. People cannot, in fact, process all of this, and that's where machines help. Classification. I will show you parts of the sky where we see these grains of sand and where we need to get the information from. So far, so good. We need AI, and it will best serve us. However, we see that whatever is done by the machines is what we've taught them to do. We need to do a training to the machine so that it searches to find an object. A huge problem that we saw in the previous presentations is bias. There is prejudice. Whatever we do, we try to feed it into the machine. Machines are not neutral. That is a key problem. It's true for astrophysics. It's true for everything we do and which have to do with machine. And you know, in astrophysics, we're looking at extreme discoveries that really change the way that we see things. And AI does not really do that well on that front. I'd like to show you one example, and I will explain how risky it is to use AI in astrophysics. Let me take the example of quasars. These are enigmatic objects at the very limits of the universe. They're luminous, the most luminous objects in the universe, and those that are further afield. There is a case that I'd like to talk about a bit later, but I'd like to show you the various telescopes. And you see Hubble and Webb. You see how they can, in fact, probe far into the universe. They can go, in fact, up to 20 million years. You see a small light that we might see through the telescopes, and they download data. And here I'd like to show you that these quasars were created in the beginning of the life of our universe, in the ancient universe, when it was about 1 billion years old, after the Big Bang. This is a galaxy, the most recent one that we have found, which was 400 million years after the Big Bang. You see the distances in billions of years, and you see the redshift here. The redshift of light, because as we see the universe expands, the wavelength also expands, and it shifts towards the red colours, and that's why we're talking about redshift. Now, let me show you the first quasar that was discovered in 1963. This is an image of the sky. This dot was the quasar. All the rest are stars. How can you distinguish one from the other? Well, that is an issue. You have to teach the machines to do so. Quasars are a bit redder because we see that their light goes towards the red part of the spectrum. So we see hydrogen emits towards the red part of the spectrum. So this line should have been here, has in fact shifted towards the right. Those which is in blue goes to light blue. The one that's in light blue goes towards green. And in the beginning we had a problem when we saw this spectrum. We said, what on earth is that? And we called them quasi-stellar objects, almost stars, because they look like stars. And we see that even though these are billion times further away, well, this is a very famous quasar that I'm about to show you. It's the biggest and most luminous object that we have in the universe. And AI didn't do very well. It missed out. And it thought it was simply a star. So this is the quasar that we see here in this image. It's this dot here. Here. Imagine if the telescope looks at a part of the sky which looks like a grain of sand in my hand. There are tens of thousands of galaxies. Most of what we see are other galaxies. Well, let's call them regular galaxies. But we also have the explosive galaxies, which are these quasars. How will we be able to identify that this is indeed a quasar or not? What are quasars? The specific one has a code name, J05294351, and look at its luminosity, 500 trillion times that of the Sun. Our galaxy has 200 billion stars. Let's say that an average one has 300 billion. So this shines as if it has 500 trillion times the luminosity of the Sun. And this comes from a very small area like our system. So we see that this is, in fact, a huge system within a small area, 300 astronomical units. This black hole is voracious. Every day, in order to survive, it must be able to consume a mass which is the equivalent of that of the Sun. And we see that everything which, in fact, is circling around the black hole creates friction, and that is why we have this great luminosity. And you see the value of Z here. We see that the time light has been traveling for 12 billion years, although this quasar has gone 20 billion years ago, because the universe has expanded until that light has traveled to us. This amazing object was something that AI missed. So when these huge telescopes was being used and we looked at the spectra, because you have to see the spectrum and whether it is shifted towards red, it was identified, and now it's the most luminous object. Now, this is a characteristic case whereby AI was not able to do its job well. Last night, I asked ChatGPT, please tell me, what are the drawbacks of using AI in astrophysics? And it can criticize itself. That's a good thing. It doesn't say that I know everything. It says I have problems in terms of bias. I have problems that the algorithms that I use are a black box. I don't know how I come to these conclusions. That's a problem when you're a researcher. And there is a computational cost. So we see that the major research centres and universities cannot foot that bill. And it draws false conclusions oftentimes. We might be looking for exoplanets, and it considers that noise is a signal, and it gives us a false conclusion. And there are various moral issues. 2 more slides to go. I thought that I could put a difficult problem to it. I said, okay, AI does the calculations faster. One more slide, please. So faster than man. There can be no doubt about that. And, even a small calculator that we had in the past would help us be faster than doing things by hand. But after we look at the universe, there are certain figures that have, in fact, a special significance. So 1 towards 137 is the fine structure constant. Without this, there would be no life on Earth. We wouldn't be here. So I asked ChatGPT, can you tell me why? And this is a key question in physics. Why do we have these numerical values? Okay, you're good at doing the calculations, but why do we have these numerical values? It says the number of this constant is fundamental, and it plays a fundamental role in the understanding of electromagnetism and the nature. But it isn't known why this fine structure constant is this. And it didn't answer the question. So AI is unable to take things further. Okay, so here you see I'd like to finish with this beautiful painting and Kanaris Tsinganos, that every form of knowledge, when sundered from justice and the rest of virtue, is seen to be plain roguery rather than wisdom. AI doesn't know this. We have to teach it. Our scriptures, our orthodox tradition, those that we experience, we have to teach AI about all of this. AI is not bad, it's immature and hasn't been taught what it needs to be taught. So, and this is the Big Bang as to who pressed the button at the time 0. Thank you very much.